Hello and welcome to today's tutorial on finding areas using integration. In this section we will show how integration can be used to find the area, big A, between a curve y is equal to fx and the x-axis from x is equal to a to x is equal to b, as shown by the shaded area in the diagram here. One way to estimate the area will be to divide this larger area into a number of rectangular strips, as I've shown here below. Since each of these strips approximates to a rectangle, the sum of the areas of those rectangles give an approximate value for A, taking note that the area of a rectangular strip is length multiplied by width. If we take a closer look at one of these rectangles, I've just drawn it here below. Let the area under the curve from x is equal to a to x is equal to x be equal to ax, and the area under the curve from x is equal to a to x is equal to x plus h be ax plus h. The area of the narrow strip subsequently, as a result of this, will be equal to h, which is the width of the purple strip, multiplied by the length, which is fx in this case here. So therefore the area of a narrow strip is approximately equal to h fx. The area h fx, which implies, if we look at our diagram here, the area, so ax plus h, take away ax, gives me the area of the purple strip, and we can now equate this or approximate this to fx by h. Now by just manipulating that formula, I can get an expression just for fx by itself, which is ax plus h, take away ax, divided by h, and you can probably see that you're going to start to recognize what this formula looks like. Now in an ideal world we try and get as many of these little rectangular strips in under our curve as possible. So ultimately we try and, by getting as many, by making h as small as possible, we will get more and more of these rectangular strips in under the curve, which will give us a better approximation for the area. So therefore let h tends towards 0. So as h tends towards 0, our equation now looks like, as h tends towards 0, ax plus h minus ax all over h is equal to fx. Now we all recognize this formula as being our first differentiation from first principles formula, so I can rewrite this in fact to become dA dx is equal to fx. So dA dx is equal to fx, so therefore dA is equal to fx dx, just by again manipulation. Now we're ultimately using integration to find the area, so how do I go from this expression dA to a? Well, I integrate my given expression there. So therefore area is equal to the integral of fx dx. So thus the integral of the function y is equal to fx gives the area function ax. And if we substitute b and a for x, we get the area between the curve, the x-axis, and the lines x is equal to b and x is equal to a, which is ultimately what we were hoping to achieve. So just to put it into general form, if I have a graph and any curve, so I'll just draw it like this, and in between certain marks on the x-axis, so I have this between x is equal to a, and I draw another line, x is equal to b, and I'm looking for this shaded area here. So I'll call this shaded area A. We can use the following equation to find the area. So a will be equal to the integral of the given function between b and a fx dx. So thus the area A of the region between y is equal to fx, the x-axis between the lines x is equal to a and x is equal to b, is given by a is equal to the integral between b and a of fx dx. Thank you.